Perfecto. Vamos a comenzar con la sesión de hoy, siendo las
Okay, so
15.
let us begin with today's session. It is 5 after 3 local time. So I would like to welcome you all who are joining us today workshop session as part of the whole workshop preparing us for the 2023 Connectathon. So today is the first of two sessions that we will be receiving from our LACCHAIN friend associated to one of the tracks that we will be having in the Connectathon, which is innovation. So please give me the next slide. I will give you just a brief introduction, and then I will hand it over to the LACCHAIN team. General context then. We have three pathways, three tracks that we're going to be running during the 2023 Connectathon, which is the second LACPASS regional Connectathon. We've already finished with all of the workshops and training cycles associated to the first two tracks, the International Patient Summary and the immunization certificates within the strategy of the Global Trust Framework. All of the material you can have access to through the Raxel YouTube channel, and we will begin with one-on-one activities with the rest of the countries in order to reinforce the technical knowledge, but also the possibility of generating all of the products that are to be generated in each of these tracks. And that's precisely what we have for the coming months. But today we are starting with the first of two cycles for the first track, which is innovation. This is where we are because we're going to be learning about digital authentication, DIDS, digital wallets, cryptographic certificates for issuing and verification, which provide support on giving security to the vaccination certificate or any other type of documents for that matter. For the Connectathon, we will be using the vaccination certificates. Next slide, please. So, very concretely, today, then, we have this first session. Next week, we will have the second LACCHAIN session. And with that, we will close these workshops that are related to the base knowledge required for the three tracks that I shared with you in the previous slide. From there on, what we have in terms of training and workshops and webinars is directly related to the testing platform, which is Gazelle, and it'll be the IHE team, the one that will be leading these webinars. The first one already has a date. That is August the 14th. This is the webinar where we will be learning on how to register in this test platform, as well as some basic concepts required. And then there are other workshops that have to do on how to execute the test and how to connect to the platform. So that's all I really wanted to add. And I would like to hand it over to Antonio and Eric from the LACCHAIN team. They are great collaborators in this whole public regional good. Thank you. Thank you very much, Carlos. Thank you, Antonio. Thank you, Carlos. My name is Eric Pacheco Pedraza, and I am a blockchain specialist on the technical side. I have several years of experience working with this technology, and I'm very happy to be able to collaborate in this very interesting LACPASS project. We will see that there are several tools that can be integrated both from the whole vaccination and health certificate and also how we're going to make that integration with LACCHAIN. We will be looking into that during this session, which I hope you will enjoy. Thank you. All yours, Antonio. Thank you, Erika. My name is Antonio Leal, and I'm a computer scientist, and I have the responsibility of leading LACCHAIN projects. Since 2019, I have been carrying out this LACCHAIN projects, and Currently, we are participating in this digital health workshop, and I'm very happy to be a member. Today, we're going to be looking at some basic blockchain concepts. Those of you who are acquainted with the technology will be able to reinforce this. Some others will learn this for the first time. We will see the public key infrastructure, PKIs, what it is about, how it works, and some of the use cases. We'll be talking about some certificating authorities, CA. These are for public keys. We will also see what a decentralized identifier is, a DID, also the trust record, and also a chain of trust. We will have a demo of what the onboarding of a health authorities is within the whole digital health scheme. And then we will take a look at the cryptographic signatures of the certificates to bring the workshop to a closing. So these are the elements that we will be seeing throughout the next hour. And if you have any doubts, please don't hesitate to ask. And the idea is to start putting some shape into this so that we can understand how it all works. Very well then. So what is blockchain? This is a distributed ledger technology. That's the way that it's actually known, DLT, that allows for multiple participants to have a secure and transparent register in a decentralized way. It's very important, that concept, unlike the ones that are centralized, which is the one that we are more used to. And blockchain, it's a block of chains that has a chronological order, and these blocks that are created are linked, and they will go through cryptographic the, so through a cryptographic encryption, which does not mean that it is not absolutely invulnerable, but the fact that a piece of data may be changed that changes the data integrity, this technology will allow to detect that participants will be able to see that there is a change, and that is why it has been called invulnerable. The blocks are created, or rather, the participants will sign, it will be encrypted, and they are visible for all the participants, which does not mean that the data is not sensitive or confidential, because basically what we're going to see, what we're going to have in the blockchain, what we're going, the best practice really is hash certain data, going through a mathematical function in order to obtain a result, which is called a hash, and that is what we are going to record in these blocks, in this whole chain. And another important principle is that blockchain contributes with transparency and trust because all the participants can see the transactions. There are some cases of a private transactions, but we're not going to be addressing these. So, what the participants that are in the net, but they have a computer. They're called nodes that play different roles, and they participate in the transactions, and it allows for the network not to be centralized. There's not one centralized element that controls the way that the data are actually working. And the validation of the block is done by some validating nodes, and in some cases, the responsibility is distributed between several, many, or a few, and there is a consensus mechanism to validate the transactions. Once these transactions have been validated, then the process reaches a certain value, and then the mechanism of consensus it says these nodes are in agreement, and that means that the block is validated. And examples of these are POW, proof of work, proof of stake, proof of authority, POW, POS, PONA. You've probably heard about this in the case of the cryptocurrencies, Bitcoin, for example. They're going from a proof of work to a POS or a POA. It's part of the consensus that we work with and that we have to start getting used to. So the networks that are based In Ethereum, use a Ethereum virtual machine, and these virtual machines are deployed throughout the network and allow for the execution of the code with intelligent contracts. Intelligent contracts are written in a special language which can automate the transactions, and this machine also keeps the state of the blockchain. Another important thing here, we are not talking about cryptocurrencies or the use of cryptocurrency or tokens. We're talking about blockchain as a technology that will allow for a decentralized functioning where different nodes can participate. And basically, intelligent contracts will automate the processes, establish business rules, and given certain conditions, then the intelligent contract is executed and there is no way of reversing those transactions, or at least not easily. And that's why this is transparency, and it makes this a very attractive technology for the record trust, which is centered individuals on organizations where there is a reliability because these are these can be fully identified. The ISO has this recommendation, ISO TC 307, and it has these three different permissions. On the left, we have a permissionless and public network. Anyone can deploy a node. It's decentralized, it's transparent, but usually has a fee in order to carry out transactions, usually has a cryptocurrency in order to fund the work of the network, and they are anonymous, and therefore they are not regulated, and privacy is usually not enabled. Bitcoin, a network where anyone can participate. There's levels of transparency, but you have to pay. You have to pay, and it's based on a cryptocurrency. So that's a completely separate case use. There are some permissioned and private networks, but they are obviously the level of decentralization is low. They're not very transparent, and only nodes can be deployed by those people that have been authorized or that have been enabled. Usually, these networks are related to one or two use cases, so they're not really scalable, and this is for trading, but also for exchange, but they've not been very successful and they have been turned off because they're for one unique use, and it either takes off or simply they are totally deleted. And then permissioned and public. This is the environment that we're going to be working with, is the blockchain system that I have mentioned. And since it's public, anyone can deploy a node, but it is permissioned. There is a permissioning committee that identifies that the person or organization is responsible and is given the authority in order to carry out transactions in the network. It can be low transaction fees, it's decentralized, transparent, it does not have a crypto, it can be no, it's non-anonymous, and the privacy is guaranteed. So going back to the blockchain, then we're working with the LACCHAIN, which is a permissioned public network, and it is sponsored or guided by the IDB lab, and it has all the support from the IDB and with the partners that we're working with for digital health. This is the largest permissioned public network in the world so far. We have three networks really. We're turning one off, which is the first test network that we created. We also have another open test network, and we have a main net where we call production basically, and there are nodes there that are functioning, and the nature is a little bit different. We have a list of nodes here, over 200, and we continue growing, fortunately. The topology of the network can be found here, and this is one of the things that we wanted to talk about. This is the LACCHAIN topology, and you will see five different types of nodes. We're going to focus on the boot node, validator, and the writer. Boot nodes are the ones that allow for the nodes to meet each other and to be able to work together. The nodes are identified, they identify the boot node, and they understand the context in order to carry out the transactions. Validator, which this is a particular type of node that have to have high availability because it has to have the consensus mechanism working and they have to be available in order to receive all the transactions. And validator and sorry, writer are the ones that are the regular nodes, which is what we're going to be looking at in the workshop. They are permission, and through a boot node, it sends transactions in the network. The boot node receives it and it does a relay to the validator node. This to have the corresponding security to avoid a service denial, but also to guarantee the growth, the scalability of the network. So the validator receives the transaction from the boots, and once that there is a consensus, the blocks are generated. In the case of LACCHAIN, it is based on Ethereum. We we use gas, but we have cost zero. So for this to be basically an inclusive and functional network, and we create blocks every 2 seconds. And it's instantaneous. The possibility for a transaction to be reverted or breached is very hard given the protocol that we're using. So Uh, when talking about blockchain, then let's talk a little bit about some of the security aspects and the PKI, public key infrastructure. I will be calling it PKI from here on. The PKI uses a asymmetric cryptography in order to have a pair of keys, public and private. With private, we sign the data, but public is for everyone. Anyone can cipher data. We can sign it then with the private one, but it can be also decrypted. But PKI is a little bit wider. It means having software policies to revoke and we're going to see the way that this actually works. The digital certificate that's going to be issued, we're going to see how it works. It allows to identify an individual or an organization associating the public keys, allowing for authentication. And with this, the individual or the organization can authenticate and they can cipher or signed data. These are the protocols that we know. It uses SSL and SSH. These are cases of the use of PKI. In the case of HTTPS, it allows for a secure connection between two users and a server. Some of the public keys infrastructure has many pieces, some relevant components that we're going to be looking at. A certificating authority, a public directory, a certificate registry, and revoked certificates. We're going to see that they can use the key or password. We will be talking about the keys. These are certificate authorities, agents of trust that issue certificates and to link identities, organizations, individuals with public keys, VeriSign, for example, and many other uh, or entities. This certificating authority will carry out a process of verification with the organization or individuals because in order to get a petition will allow for a certificate signing request and a whole set of information of the organization or the individual is put in there and the authorizing organization will say whether it grants it or not and if it's a trusted entity in order to provide a digital certificate. Once the organization has been verified, the CA will issue a certificate called XL509, which is signed by this CA with the corresponding private key. And what's in this certificate is the information of the organization, the individual, the public key, it could be more than one, and the period of the validation of the certificate for them to be able to use their public key. Certificate X509 is a certificate supported by the ITU, which is the International Telecommunications Union of the United Nations. Down here you have the links of the Internet Engineering Task Force. It's a digital command that securely associates pairs of cryptographic keys with identities like a website. And that's why you can see that there is a secure connection in the internet and it allows you to see who the certificate was issued by and you will see in the URL or the domain that has the corresponding digital certificate associated to it so that you can have a secure connection to a website. So this specification of Excel 509 has well a certificate. Today we're looking at version number 3 with the different components, a revocation list of the certificate because if any certificate has been compromised or if someone has been removed, well, we can have a rotation and we need to have a place whether a certificate has been revoked or not, and an algorithm for the validation of the certificate route. So going back to the certifying authority, Certificate X509, we can verify the signature of the issuer of the certificate, which will allow for the integrity and the validity of the certificate and also the public key. And the CAs issue and sign certificates for them to be able to certify other certificating authorities. And when there is a whole chain of certifications, then that is called a chain of trust. An important component then of blockchain and this whole concept of identifiers, and this is an important standard, is the DID, decentralized identifier. It's a standard that is supported by W3C. It was approved. There were proposals for several years, and last year it was approved as a standard. According to W3C, it's a new identifier that allows for decentralized digital identity that is verifiable. It can identify a subject, an individual, organization, an entity. It's totally flexible, including abstract entities. This is a little bit more technical, but basically it says that there is a URI that associates a subject with a DID, and it allows to say which are the authentication methods in order to test some of the properties that that DID in particular can have. The other thing that is important is for you to see what a DID is like. It has three parts, and these parts can be a little more complex, but basically it has a scheme identifier. It's a DID, as if it were an FTTP, for example. The method is how we're going to have access to that DID or where. There are different flexible aspects, and then the specific identifier. It's called a method here. And if, for example, in this particular case, if we had a method here, well, we have this identifier, and this would be all the DID. And another important point is that a DID can represent a pair of public and private keys. So this is important, especially in the demo, you're going to see why we're using the IDs. So reliable records or registries, what we're trying to do here is to bring together all of these pieces because what we're going to be doing in the innovation track is precisely having one of these reliable records from authorities or countries and the digital certificates from the health entities within a scheme called a trust registry. The trust registries are managed by authorities or governments, and basically they are reliable, they can be trusted, and it has the registry of all of the entities that are involved. And these, we can have one large trust registry, but it can be partitioned, which are part of different activities or different aspects of trust that are registered there. There is a particular information for the organizations or individuals depending on the design of the registry, and they are associated to digital certificates and the public keys associated. So let us look at the case use of a public directory. This was developed by Eric for LACPASS. This is the URL of the GitHub, the repository, where we have all of the description, and there are two important considerations that we need to mention before I hand it over to Eric. We're going to be using a decentralized identifier for each entity that is part of the trust registry, and an entity it can have multiple DIDs, and we're going to see what this consists of. And then let me hand it over then to Eric. Thank you, Antonio. Let me share my screen so that I can go from. Okay, you can see my screen, right? Okay, let me put it in slide show, but I will be switching from this presentation to another screen though. So what I would like to share with you is how all of that theoretical basis that Antonio has shared with you can be grounded to the project, to the LACPASS project, and how we're using the different concepts that Antonio explained within blockchain, more particularly in the case of LACCHAIN, which is a blockchain, but that has a whole legal and governance layer that it makes it ideal for the case uses like the one that I'm going to be describing now where different health entities participate. For this then, on the LACCHAIN network, I will be focusing on the mechanism that is built on top of the network that allows to create a trust environment in this particular case, including all of the ministries of health. So basically, here, in order to create this trust environment, first you have to know who they are. You have to learn who are the different participants in order to create this trust. So, putting this into LACCHAIN, applying this to LACCHAIN means that each ministry is enrolled, is registered within the network, and then each entity can interact and the things that I want to communicate to the other members in this environment will allow them to see, and they will be asking and consulting to the same blockchain, the LACCHAIN network. If, for example, if we make a change, and we say, I'm revoking or I'm adding a new key or a new certificate or a new credential to sign this health certificate, my peers, which are the other ministries, will immediately realize that that has happened. And that's basically what it is. So adding or using blockchain in order to do this allows for inheriting all of the characteristics that a blockchain has. Transparency, because all of these transactions are registered in the network, and these are public operations, and that should not cause any issues in terms of security, but also they are transparent and can be consulted at any point in time. Also, in one single network, the different members that participate in a given context, like this project, can have all of the information updated and duly available. So for this, then, we have two intelligent contracts. One of the things that Antonio was talking about. One of these contracts is a public directory, and the other one is the trust, the chain of trust. In this public directory, it's almost like having an agenda where the agenda has been orchestrated by a committee. In this case, it could be, let's say, Raxel. And what the committee does is that it'll be onboarding the different participants, that is to say, the different ministries, and it will add them first to the public directory. That is to say, the Ministry of Peru says, for example, to this committee, this is my DID, my identifier. Remember that Antonio has described it, decentralized identifier. How it will be created, we'll be looking at that in just just in a few more minutes. So if you want to onboard, they have to share the DID and also some additional information that we will look into also later. This is the onboarding point, and that will allow them to come into this trust environment. The public directory says this DID from the Ministry of Peru, in this particular case, has a certain identifier public data. Basically, in the name, it'll say Ministry of Peru and some additional information that can be added, but that basically will allow for the identification of a code, which is a DID, with data that is legible by humans. This is one of the components. Okay, public directory. Let's go on to the next one. In this case, it's the chain of trust. And in this chain of trust, we can imagine this like the once the committee has put this entity in the public directory, then they come to this second contract, and in this contract, they start adding the ministries. He starts adding the ministries as you can see here. Let's say that this ID1 here. I mean, you can see the cursor, right? So let's imagine that ID1 here is the committee, the Raxel committee, the one that is orchestrating the governance of the different ministries. Raxel then onboards, or it's the main entity, and in this case, it starts onboarding the different ministries, Ministry of Peru, Ministry of Chile, and this could be, I don't know, the Ministry of Colombia, let's say, so that all the ministries then are not only part of the public directory, were duly identified, but also here as part of this second component. And this will allow for each ministry to be able to add other entities below the ministry. For example, let's say that this third circle, which I said was the Ministry of Colombia, they want to delegate their trust to a sub-entity that is part of the ministry that can also sign health certificates. So what the Ministry of Colombia does we can say that it says ID 31, and it says that here too. It means that the Ministry of Colombia, in my example, is creating its own sublist within this environment, and in this sublist, it is adding the entities that it is delegating trust to. So here we have then this concept of a chain of trust, where the different entities that at the beginning were added by a general or main committee has then the possibility of adding additional entities underneath them. And these entities in turn can also add others. So this concept is a controlled concept. It is controlled by the depth that can be determined, that can be set up. In this particular case, the committee or cell could say the depth is only going to be 3, for example. That is to say, the Ministry of Colombia can add a sub-ministry in a region, and this sub-ministry can add another health center further down. And since it's a maximum of a depth 3, it cannot continue going further down. Maybe we can say that 3 is too much and then only 2 are needed. But the thing is that this component that sets the foundation for what the extension that we can give in terms of the change of trust, delegating trust to other levels further down. But why do we do this? Because let us remember that if each of these ministry are part of different countries, when we want to consult for a certificate that was signed by a sub-ministry further down, which is this example, or even at this particular level, this first one, which we said was Peru, signs a health certificate, quickly, very quickly, then, since this information is public, it's public information, others that want to consult this intelligent contract will be able to come here and very quickly realize which are the decentralized identifiers that have been authorized. And that's all. So we could say, but how can a DID sign certificate? We will see how we can make this a connection between this identifier, which is the main pillar, with the different cryptographic certificates that are signed, including the health certificates, but we will see that further on. The important thing here is to be able to understand how we can create these all tree of trust with this concept that we have called chain of trust, and that has been created on the basis of the features that are provided by a blockchain. So this is basically the same, but now looking at it from a different perspective. Here we can see that this is, let's say, Raxel, and it doesn't matter the different sub-entities that we have here at this level. They are simply listed here. In level 1, the countries. Level 2, the sub-ministries, and then further down, the other entities. And it might be enough to remain at this level, but the idea is just to show you what can potentially be done with this tool. So, this is enough then for us to do a demo and to see how we can actually do it. And I hope that it's clear and concise enough so that we can get a good idea on how the tool works. Are there any questions so far?
Ya. Entonces, este repositorio es
So
público.
this is a public repository, and we can access it at any point in time. I've got it here. This repository, which is the LACPASS client, can be downloaded. And if I have time at the end, I can show you how we can set this repository. but just for given time constraints, I've got it all set up here. The thing is that we can clone this repository, and basically what I do is I copy one of the environment variables and envprod. I've copied it from example. When we download this file, you will see there's going to be one file called example, and I'm simply copying it in .prod. And this has all of the variables that are needed for us to directly interact. Now, I'm not going to do any setup of blockchain because this is directly connecting to the LACCHAIN. So it has been set up for us to interact directly with the network.
No me voy a enfocar tanto en el setup, sino me
So
voy a
I'm not
enfocar.
going to focus on the setup, but I'm going to focus on the final experience, what we as an end user would like to see, how it works. And for this, what I'm going to do is, first of all, let us imagine that we have the repository, and what I'm going to do is I'm going to start it, to initiate it. There it is. There it is. Okay. Now, what I will do is I want to exit here so that you don't get confused. Let me open up a new terminal. And here in this new terminal, what I'm going to do is I'm going to go into the repository to a folder which is called docs. And once I'm in the docs folder, we can see what we have here. We have an executable file, which is this one here, client-helper.sh. This has been created for you to quickly execute these steps. So first of all, I'm going to give execution permits to these executable so that I don't have any issues, and I can do that with this command. And then let me clear here. We're going to see what we can do with this. So don't pay attention to that just now. I will explain this later on. But what I'm going to do is I'm going to initiate this execute.
Problemas.
I'm going to go to a bash in order to avoid any issues. There it is. So since this is an executable, it asks what the connection point is, which is what I did just a minute ago, which is this here. This is what I run, and it's running in the port 3010, and I've got it here. By default, it runs on this port, and I'm going to put the URL. There it is. So this is direct. We only have 5 options, and that's all there is to it. Everything that I have explained is this summary of 5 things that we can do. That's all, really. So the first thing that we can see is that I talked about 2 concepts. I talked about a public directory where we have the identifier, the DID, and the data, and then the chain of trust, and that's all. So let's imagine that I am the Ministry of Peru and I want to do this flow. Basically, what I have to do is to run this. And since I want to be known in the public directory, first I have to identify myself with a DID and then pass my DID data. I am the Ministry of Peru, and then some additional information that may be required. And we first create then a DID. And it says here, write a CD to create a new DID. So I'm going to write a CD, and that's it. And this creates a code which creates a DID, and that's it. So this is the first step. The second step, imagine that we want to enroll here. So now I'm going to the committee and I'm giving them my DID, my identification information, and I need the Raxel committee, in this particular case, to add me within this chain of trust. So for this to happen, I will give them a key that I will always access with and that I can use to add any other entities below me if required at any point in time. So in cryptography, there is asymmetric cryptography, public key, private key, and I have to give them the public key of the public key of the credential that I will always use to access this shared environment. So what I'm going to do now here is that I will create that key that I'm going to make changes with, and I will give to Raxel my public key. But you have to be careful because not only am I going to create it, but I'm also going to link it to my DID because my DID is not only this identifier, which is quite long and alphanumeric, but it also has an important feature, which is that it allows to establish a link between different cryptographic credentials to this DID. And how can I do this? Well, we can go here, we can run then the client helper once more, and I can do this then. And since I've created my DID, then the next thing will be, I want to create a new chain of trust manager. The manager, I will only have the private key at the Ministry of Peru, but the public key I will share.
CM.
So we're going to create this manager, CM, and it's going to be created and it says, tell me the number of days in which this manager will be valid. So I'm going to say 3,600 days, just to give an example. So what's happening now is that there is a connection being established between the key, between the DID and the manager that's being created here, which is a cryptographic credential. And it's giving me here a super summary. It says that the DID that I created just a little while ago that is up here, which corresponds to the Ministry of Peru in my example, is this one here. It ends in 86C, as you can see up here too. And then it gives me the manager data that I have just created. So, conceptually speaking, what is done on this onboarding process with this data, I would hand it over to the committee. The committee can add me in the public directory, but it also it gives me permission with this environment. So as a Ministry of Peru, I would be this circle here, and the public key will have already been set appropriately, and I have the private key. Me at the ministry, I can use that then to add some additional entities. That is the onboarding process, and there's nothing else to it. All of the details that could make this a little longer have been summarized in order to do it like this. But as you can see, there are about 50 minutes of this whole technical side where all of the foundations are well explained. Now it only takes a couple of minutes. Now, in closing these, I'm going to run this client here again, uh, just to do the very last thing that I want to show you. This is one thing that we can improve, but basically I am connected to the backend that is running in the other terminal, and we can ask Eric, me, has told me how to do the onboarding. I've created my DID, and let's say that the committee has already onboarded me as part of this contract. And I'm not going to explain that right now because that is another component. But let's just say that you were onboarded. That information is shared over the email. So what can I do now? What is this for? So as we were saying a little while ago, the DID allows me to establish an association, a connection between different keys that I can sign with the health certificates, and that's what I'm going to do right now. So I'm going to the DID, I'm going to associate a certificate XF509 that I use to sign the health certificate. But for this, I'm going to click on this option that I haven't used yet, associating an X509. So AX. Let's imagine that this X509 is the certificate with which the health certificates are being signed with. So in this particular case, I'm indicating here the route, the path in my computer where this certificate is. I put it in a folder that is called certs, and then we can go into another folder called DSC, and within DSC, this is the path dot CRT. It says that the file has been found and it's associating it, and it's done already. Again, here it went to the blockchain network and it has left an association between the PEM that we often hear about and this X509 certificate, but only the public component has been associated to the DID, and this association remains in the network because as a part of this trust environment, we're establishing this association for other members of the organization can carry out this verification that that DID is associated to this key, the key that we are signing the health certificate with. So in closing, we can, at some point in time, if we wanted to de-associate this key, I don't know, let's say that now no longer this is valid, we can then say that we can disassociate the key, which is probably not the most common of cases, but I do believe that we can still share that in this innovation session because it's something that we can do. So I'm going to write here DX, which is dissociate, and the same one. I will now disassociate. So let me put it here. It's founded and it says, tell me how many days back, or you can write a 0, saying that it's only as of now that this certificate it has been revoked. I'm going to put 0 here to say that currently it has been revoked. That's it. And then the disassociation process begins. And then this means that the certificates that were signed with this key, with this PEM, will with the private key will be invalid. But before that date, before this moment, are still valid. So in a summary, that's what can be done. We have seen then a summary of the public directory. We've also seen the trust network or the chain of trust. And we can also see the DID and how we have associated different keys for different purposes. And one of those purposes, which is the main one, is to be able to associate to the DID the public key, and the private key is the one that is used to sign the health certificates. So I can see that I have run out of time, but this is what I wanted to share with you, and I am here to answer any doubts if anyone has any.
Carlos, te pasamos el...
Thank you, Eric, and Carlos, I hand it over to you. Thank you, Eric, and thank you, Antonio. We do have 1 minute if there's any particular question, but if not, do not forget that you can ask me over Slack or some of the other channels that we have enabled. No hands are up, so it is important to say that this is the first of 2 sessions. This cycle will end next week. And of course, all of the material, like the recordings, will be made available in the Raxel website, in the Moodle, but also in the YouTube channel for you to check them later. And when checking it again, maybe some doubts will come up. This is a track that is optional in the Connectathon, but there were several that were highly interested, and we believe that it's high impact. So the idea is for you to join this, and it has been simplified for all of you to try and get excited with this. And it's only two workshops, but the idea is for us to revisit with each of the countries on a one-on-one basis, the three tracks, so that we can be well prepared when going to the Connectathon. Tomorrow, in the technical committee, we're going to be talking about some deadlines and some definitions that have already been made available. So we're going to have new information tomorrow in preparation for this whole set of follow-up meetings on a one-on-one basis. Thank you so much, Antonio and Eric. I will see you next week. Thank you to all the attendees, and we will see you soon next Thursday, same at the same time. Thank you so much.